This video will be talking about the second pair of angles formed by a transversal. But here we are going to solve for unknown measurements. It's always important for us to start looking for the relationship between the lines cut by a transversal. In this case, transversal line T cuts line E and line F at different points, and that these two lines are parallel. Now that they are parallel, we could actually go towards the special relationships of angles formed by a transversal. But before we go to the dynamic process of computation, let us first consider the angles with the same variable. As we are solving for in angle 1, the value for the variable x, let us use the angles for with the variable x. Okay. These two angles here, if you are still in confused with which pair of angles are we talking about, we have five pairs. We have corresponding angles, alternate interior, alternate exterior, same side interior, and same side exterior. Just simply look at the relationships between them. Number one, they are both found in the interior. That would mean corresponding angles will be scrapped, alternate exterior will be scrapped out, and same side exterior will also be scrapped out because the angle pairs with are considering interior angles would be either alternate interior angles or the same side interior. So between these two, which of the two angles now pairs is possible? Now, if we're going to look about the placement of these two angles with respect to the transversal line, they are found on opposite sides. So they are actually called to be alternate interior angles. So that's the first consideration here. They are actually called to be alternate interior angles. Now that we have established the type of angle pair formed by these two angles having the same variable, again, same variable is very important because if you're going to talk about this angle here and the angle y, you might end up dealing with an equation with two variables of which none of them are known. Okay, so we are going to look at the relationship of those angles having the same variable so that we could come up with an equation later on with only one variable that we could solve with the processes of linear equality rather. So again, we have established that they are altered interior angles. What is now next? Since we are assured that they are parallel lines as given here, we can now use those four special relationships in a form of a postulate in four theorems. But out of those five relationships, only one of them are talking about alternate interior angles. And that is actually given by the AIAT, or also known as the alternate interior angles theorem. We have already proven this in our module, so no need to prove this at this time. This theorem tells us that if two parallel lines are cut by a transversal, again, parallel lines as given here, then the alternate interior angles are congruent. If we say congruent, the two angles have the same measurement, or the measurement of one is equal to the measurement of the other. So after this identification here, we can use that statement, congruent, same measurement, equal measurement, by equating the two angles here. So if I will be using 2x minus 17 degrees here, sorry, that's degrees, it is just equal to the measurement of x plus 24 degrees. And how did we come up with this? Again, we have come up with this using this theorem after we have satisfied the type of angle pair formed by the transversal. And then definitely we do have a claim for parallelism here. Now that we have this, it's just simple solution for linear equations. So we could actually use here, we could add both sides by 17. So I have now 2x, that's 0. This is by addition property of equality. X plus 17, you have 41 degrees. And then by subtraction property of equality, subtract x both sides, we will end up with, sorry, that's just x is equal to 41 degrees. Right? Now this should be the value for the variable x. Should be, I am saying should be because we are yet to check. So we could actually again use a little bit checking here. And to do that, we need to satisfy the equation here we have formed earlier. That will be 2 times 41 degrees. I have already substituting this one. And by substituting, I'm going to use question mark. The other side, that's 41 plus 24 degrees. I forgot to place degrees. Very important to place degrees because that's the unit. 2 times 41 is 82 degrees minus 17 degrees. Is this equal to 41 plus 24, 65 degrees? Our goal here is to make sure that both sides are equal. So we have here 65 degrees is equal to 65 degrees. They are now equal. That would mean this is the correct value for the variable x. Okay? We could just simply end here, but we could also add additional checking. Okay? When we substitute this value to any of the two or both to both angles here, the purpose for that is for us to have an easier solution for angles y and angle z later. So if we say 2x minus 17 degrees, when we substitute x to be 41 degrees, that's actually given to be 82 degrees minus 17 degrees. That's 65 degrees for this angle here. And as for x plus 24 degrees, substitute, you have 41 degrees plus 24 degrees, you will still end up with 65 degrees. And as you can see, the values for the two angles having the same value for the variable x, which is 41 degrees, are the same. This is also another checking that the alternate interior angles formed when a transversal cuts two parallel lines are congruent or have the same measurement. But aside from for this to be a checking, we could also use this to solve for the remaining items, the value for angle y here and angle z. Right. To solve for that, let us pick angle y, that's the for number 2, and any angle using the variable x. Why do we use any angle using variable x instead of this angle z here? Because again, angle z is unknown, angle y is also unknown, so we will just end up with two unknown variables, and that would be make our computation very confusing. Since we already have solved here the value for x, we could use any angle having the variable of x and relate it with angle y and look at their relationships. I'm talking about this angle y here and the angle having the measurement of x plus 24 degrees. As a reminder, we could always use the pairs of angles we have learned in the previous lessons, specifically the concept of vertical angles and angles forming a linear pair. In this case, angle y and the angle which measures x plus 24 degrees are angles forming a linear pair. And by linear pair postulate, it tells us that these two angles here are supplementary. If we say supplementary, the sum of the two angles or the measurements of the two angles must be equal to 180 degrees. Again, the sum of the measurements of the two angles must be 180 degrees. With the use of that simple statement, we can come up with the equation here. Again, the sum of the measurements, that would be y plus x plus 24 degrees, must be 180 degrees. Now that we have this equation, we can now look at the value of y. We have two variables here, but we already have solved x earlier. So the first method here is simply substitute for the value of x and then compute for the value of y using the properties of equality. Or we could always use the value that we have added here earlier to be the checking of number one, but could actually help us for number two and even number three. Because x plus 24 is already solved to be 65 degrees. So if we're going to do that, we only have y plus 65 degrees is equal to 180 degrees. Now we are left with one variable and just simply apply property of equality, specifically subtraction property of equality here, minus 65 degrees. We will end up with the value for y to be 115 degrees. So as you can see, we always start with variable x in this given figure because that is the value for that is a variable which is present on two different angles, and then we use that to solve the rest. That's for number two. As for number three, let me go back here, or let us use the angles here so that we will not have many um, scribbles here. Look at the relationship between angle z and this angle here with with the value of 2x minus 17 as its measurement. We already done with linear pair postulate or angles forming a linear pair. And if you're going to observe this, angle z and this angle here with the value of 2x minus 70 degrees are vertical angles. And by vertical angle theorem, vertical angles are congruent or have the same measurement. Okay. Again, I am saying here postulates, theorems. That's why very important for us to be guided from one lesson to the other. So vertical angles are congruent, have the same measurement. So we can just simply say that z must be equal to the value of 2x minus 17 degrees. So again, we have the value for x here. We could always substitute or use this value for 2x minus 17 that we have solved earlier using the same value for x. So simply substitute the whole value of 2x minus 17. Z is equal to 65 degrees. Okay, so this is the purpose for this additional scribble here. Okay, you may not need this because you already have checked this earlier, but we have added this another form of checking number one for us to have an easier solution for number two and number three. So the key in this problem is again, look at the claim to be parallel lines. Second, look at the variables forming or having the same, look for the angles having the same variable and decide or establish their relationships. And then since we have the claim for parallelism, we can use the theorems or postulate found in our module to develop an equation, which could later help us solve the intended variable. And that in turn, intended variable will be helpful to solve the rest. So please practice on this and look for other examples similar to this so that you could always verify your improvement. So we still have another pair of angles later on. So see you on the next video. Goodbye.